Okay, so by now you're used to dealing with exponents, but maybe not always sure what happens when an exponent is negative. Like, for example, 3 to the negative 1. So in order to show you how this works, I'm going to use a table. I'm going to skip down a few for now and just do some powers of 3. So 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27. So this is the function y equals 3 to the x power. The x gives you the exponent. Let's look at the pattern in this table. So as we increase in this table, we are multiplying by 3. 3 times 3 gives us 9. 9 times 3 gives us 27. So if we were to go backwards, we would divide by 3 as we move up the table. So 3 divided by 3 is 1. This way our pattern continues so that 1 times 3 gives us 3. That being the case, that shows that when 3 is raised to the 0 power, it's equal to 1. And that's actually true for any number. Any number raised to the 0 power is equal to 1. So let's continue. What if we continued going backwards in our table and we made x negative 1 or negative 2? So again, moving up our pattern here, we would divide by 3. 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. So we can see here that when you raise 3 to the negative 1 power, when x is negative 1, the value is equal to 1/3. So 3 to the negative 1 is 1/3 that we're dividing instead of multiplying. 3 to the negative 2 would be 1/9. You could also think of it as 1/3 squared. So there's still 2 factors of 3, but again, instead of multiplying by those, we are dividing. So once again, 3 to the negative 1 power would be 1/3. 3 to the negative 2 power would be 1/9. Say you had 3 to the negative 3 power, that would be 1/3 cubed, which is 1/27. So in general, when you have any number to a negative power, that's equal to 1 over that number to the positive power. So instead of that many factors multiplying, we have that many factors dividing, or that many factors in the denominator.